All right, welcome back, everybody. So here we talk about international environmental law policies and agreements, right? Some big ones. Okay, and yes, first to clarify, this is the ozone hole over Antarctica, though hold off on your total thoughts on that one for a moment, though this is a really, really good depiction of that. Best ever. Okay. There's this thing called ozone, right? So if you've been like, okay, so lightning strikes, right? And then you go outside and you're like near it, you might have smelled this, right? Although it actually has this property where after you smell a little bit of it, it temporarily kills your sense of smell to where you can't smell anything. You don't want to breathe this in, right? Sometimes people will use ozone generators for reasons, right? But it's poisonous. You don't want to be around it, and it can be very dangerous, very harmful, because when you breathe some of it in, right, once you learn to recognize that, you realize that it kills your sense of smell to where you can no longer tell whether you are breathing more of it in. You don't want this. This is bad stuff, right? Now, it is naturally occurring, right? It naturally occurs at different places in the atmosphere as a sort of mutation of atmospheric oxygen, right? So atmospheric oxygen is O2 molecules, right? Just two of the little balls, not all three, right? Gets struck by certain kinds of light that the sun emits in the ultraviolet spectrum, and it mutates it into ozone, right? Now, sort of ironically enough, ozone also has this property where when it is up in the higher part of the atmosphere, not down where we are or, where we talk about surface level ozone, but where it's much higher up in the stratospheric layer, it blocks UVC, right? And just to remind us, right? Okay, so not all light is created equal. Some light is low energy, like infrared, and some light is ultra high energy, like ultraviolet light, right? And UVC is the highest energy of the sort of ultraviolet light that you can get. You don't want this. It causes cancer, it causes mutations and damage to the environment, including sea life, including life on land. It can hugely damage a person's eyes and do all this other sorts of stuff. It is bad. There is no reason why a person should want to have any of this, right? But then it's good that there is this ozone layer, right, that blocks the UVC from being able to get down to the surface. And just to say it one more time, right, ozone that's high up in the atmosphere is good. You want that stuff. It stops some of that really, really dangerous, harmful light from the sun from being able to reach people or animals or fish or anything else where it would destroy them, right? Ground level ozone, right? When we talk about like ozone pollution, or you get on your phone and you see that there's like high ozone levels, that is talking about surface level ozone, which is really bad, right? But it is a totally different sort of thing from ozone that is higher up in the atmosphere. Not the same. So surface level ozone is bad. Stratospheric ozone up in the atmosphere is good. Okay, so there were a pair of scientists back in the 70s at UC Irvine. These are American scientists. Later on, much later on, like 20 plus years later, they were actually given a Nobel Prize for this research. But at the time, they were just chemists, right? They were just researchers who were probing around for problems that they thought were interesting, right? Things that they were personally hooked by or engaged in, right? And they did these series of experiments, and eventually what they found is that ozone could be destroyed by these certain chemical compounds, right? These things called chlorofluorocarbons. Now, you don't need to remember that whole word, but where does that come from? Chloro is like chlorine, right? Fluoro, like fluorine, carbon, right? You put it all together, you got a chlorofluorocarbon, which is hard to say, right? CFCs. Now, these were in widespread use for a long time, especially, things like old refrigerators, aerosols, and certain kinds of foams, right? Part of the reason why old refrigerators and freezers are different, right? The ones that are like pre-1987, as we'll see, right? So they did this research, and they eventually found that these CFCs could destroy ozone, and that these things would hang around in the atmosphere, and said, hey, there might be a problem here. But that was the end of the story for them. Didn't get serious until later on. And this individual is a British scientist, I'll have to put the name in a note, right? Was at a research station in Antarctica and started to notice that the ozone at certain times of year would just drop. I mean, from like normal levels all the way down to like rock bottom. And he had the idea to see, okay, is this a one-time thing? Is it happening in the past? And he went back into the historical record and found that it had been dropping significantly over time. So this was the sort of data set that he was looking at, right? So to clarify on the timeline, right? So here in like the mid-70s, right, is where these folks published their research, right, saying that these chemical compounds were destroying ozone or could destroy ozone, that there was the potential for a big problem there, right? But notice the ozone was already starting to drop off, right? So this is our good ozone level on the y-axis here, right? Starting to drop off and starting to really sort of flatline, right? In 1980s, whenever this was first sort of measured, right? And he sounds the alarm bells and tells everybody in the entire world, and because of the fact that this is a shared thing, this big hole in the ozone, because everybody has to share the same ozone layer, and it destroys wealth, right? Destroys the wealth of everybody. There was a collective action problem, and now a collective action solution, right? This thing called the Montreal Protocol, where countries got together, they were convinced by the evidence that there was a huge problem. They figured out, thanks to this research, what was causing the problem and started to shift away from it and figure out what they could do, right? And they got together and they agreed, right, that they were going to stop emitting these ozone depleting substances, right, which are not just CFCs, right, although as you can see that's the lion's share of it, but these other things as well, right? So starting in about the mid-1980s, people saw the ozone hole and started this, precipitous drop-off, right? This is a success story, right? This is a case of people coming together, talking to each other, seeing that there is a collective action problem, and solving it, right? In a way that ultimately preserves this ozone layer and makes everybody safer and better off. And as you can see, it is much lower now than it was. Like, this is rapid action at the scale of, governments and at the scale of every country on Earth, right? Ultimately, there's sort of a delay, right? So here in the 1980s is when they stop emitting these substances, right? But the ozone layer doesn't start to sort of bounce back until later. There's sort of this after effect, the after shadow of all the damage, and in fact, worst ozone ever was in 2006. But every single country on Earth joined this Montreal Protocol, the original one, right? Every single one of them that exists. Not officially countries for these two, right? Belongs to Denmark. Anyway, 100% cooperation. Everybody engages in a deal, even people who don't have any reason to get along with each other, right? We had the worst ozone, especially over Antarctica in about 2006, but there is strong reason to believe that it is bouncing back and getting better, expected to make a full recovery sometime in the next couple generations, right? Next international agreement would be on climate change, right? So here we have, individual selfish actors, right, enriching themselves, polluting the atmosphere. Everybody pays the cost while one person privately benefits. This is a collective action problem. It needs a collective action solution. The research on it is clear. The cause and drivers are clear. The consequences are not totally clear, but it's like with smoking, by the time you know for sure whether it causes cancer, it's too late. So stop doing that. So mechanically, legally, it kind of works like this. Countries have to submit these climate action plans every 5 years. It is said to be legally binding, but there is no enforcement mechanism, so it kind of isn't. There's two goals as part of this, right? One is to keep global warming below 1.5 C, which is about 3 degrees Fahrenheit all over. Goal number 2 is to keep global warming below 2 degrees C 4F all over. Importantly, right, each step is significantly worse than the last, right? So the original goal was to keep warming within this level. There is increasing reason to believe that we have already failed on that goal, that warming has already surpassed that. However, this particular target based on emissions is still extremely possible, right? Ultimately, right, unlike the Montreal Protocol, there were many countries who both signed it and put it into action, right, implemented it, made it happen. There are some other countries which are not part of this agreement for reasons and withdrew, right, and no longer agree to these plans, but most all of them have. Just to put this into perspective, right, so there is the do whatever you want scenario, which would be horrible, right? There are current policies in place which are expected to go about here. There's what countries agreed to, and then there's these much better pathways. And just real quick, it's important to realize, right, the Earth is not going to be destroyed, all right? There is no saving the Earth versus destroying it. If you see those as the only two options, then you lose. You're a sucker, sorry. Each one of these scenarios is worse than the one below it, right? So anything to bring the world off of these outcomes is good. Every little bit matters. Just because you can't hit the perfect pathway doesn't mean that, you know, everything is lost, right? But this pathway, the 1.5C, is probably already gone. Like, the world is probably already hotter than that. However, every bit counts, right? We do the fast forward version on this, right? So the goal globally is to get net zero carbon emissions, right? To where countries are putting just as much into the atmosphere as they are taking out of the atmosphere, right? Net zero in terms of how much they add, right? Berkeley and the folks there have talked about the steps needed to do this in the United States, right? But importantly, again, being able to set emissions to zero in the US does not solve the whole problem. Bigger problem is what's coming out of developing countries, China and India, and who would pay for them to be able to do this? We have the money, and at this point we have a lot of the will to do it, but other countries do not, which makes the picture complicated, and we'll just leave it there. Convention on Biological Diversity, going to be the last one of these we talk about, right? UN, 1993, signed by every country in the world, right? The goal was to promote sustainable development and protection of things that generate wealth, like what? Well, ecosystems, species, genetic resources. You remember way back when we talked about biodiversity at 3 levels, right? Ecosystem biodiversity, species level biodiversity, and genetic level biodiversity. Well, here we get to see that again in this context, right? 3 different ways that this tries to protect these resources and to help countries to cooperate to share them, right? Ultimately, genes are information. Spreading genes is spreading information. So there's really no reason why you couldn't have, you know, genetic information in one country that is shared with all the others, right? That ends up creating more wealth in those other places, gives them access to information and options, and there's ways to make sure that that country, you know, gets something in return for their genetic resources. There's lots of complications on this, you know, countries which have tons of biodiversity and biological and environmental resources, but who don't necessarily have the most cooperative or developed governments and who are struggling with certain issues, right? Brazil would be one example of this, where yes, they are developed and modern in many ways, but not like, you know, the United States or countries in Western Europe, right? And so finding some way that countries can work together to share those genetic resources and preserve, right, things that everybody is collectively interested in without, you know, making it a bad deal for Brazil is why this exists, right? And there are 3 goals of this, right? Conserve global biodiversity levels, right, which is very much linked to deforestation, habitat loss, and climate, right? But that was part of the goals, to define what sustainable use of these things look like, which is not easy, and to ensure more equitable sharing of genetic resources, right? To get around the idea of stealing genetic resources from others and making sure that people are compensated while also acting in collective interest, right? Countries coming together. It was later amended, right, to kind of define, you know, what GMOs are and how those should be regulated, which is obviously a huge benefit, but also potential issue between countries, especially, right, in the way that those can spread between countries and who should own it and who should make money, and to follow up on the legal framework needed to do this, right, and to share, right? And genetic resources in many cases mean these different varieties of livestock, which can be shared, and these sort of seed libraries, right? And with that, right, those 3 things, the Montreal Protocol, Paris Climate Accords, and the Convention on Biological Diversity, we are ready to move to the United States specifically.